This meeting is being recorded.
Welcome to Cornerstone Home Inspector Education Center. Tonight we have inspecting residential boilers and hydronic heating systems. If you have any questions, please feel free to jump in. I will be presenting with Scott tonight. I'll be communicating and then Scott will be jumping in when appropriate. And then you'll get your certificates by noon tomorrow. And we have a lot of upcoming events. So take a look at our calendar of events, and our new newsletter, our August newsletter is out for download. Okay, and keep yourself muted if you're not already muted. Thank you. Okay, so tonight we are going to be going over residential heating systems. We're going to be able, by the end of this webinar, to identify the types of systems, spot critical defects, recognize common defects and safety concerns requiring immediate attention. We're going to go over what kind of inspection sequence you should be doing and describe the inspection approach for hydronic and steam systems. And then we're also going to go over reporting with clarity, clear observations, implications, and recommendations. Why boiler inspections matter. Boiler and hydronic heating system inspections are critical components of residential home inspections. These systems directly impact occupant comfort, property safety, and inspector liability. A thorough understanding prevents missed defects that could lead to costly failures and dangerous conditions. Boilers operate under pressure and involve combustion processes. Unlike simple furnaces, they require specialized knowledge to evaluate properly. Understanding their operation, common failure modes, and safety systems protect both homeowners and inspectors from liability exposures. We're going to hit major points on these systems. We're not going to be pulling these systems apart, going over every single item in the system, just to let you know. Standard of practice for the 5 states that we're in. Here are the breakdown of the heating inspection requirements. As always, if you're watching from a different state from Connecticut, reference your own state standard of practice too, but this is a combination of everything. The inspector shall inspect installed heating equipment, energy sources, and the fuel type, describe the heating equipment, distribution system, piping and ductwork, and fuel type. You want to operate the systems using normal controls. That's your thermostat, when conditions permit. Open readily accessible manufacturer installer access panels. Observe and report on normal operating controls and automatic safety controls. Observe and report on the exterior chimneys, flue piping and vents. Observe and report on heating distribution systems and their installation. Observe and report on visible flues, dampers, and related components. Note the presence of a heat source in each habitable room. Report any absences. Inspect visible and accessible portions of the heat exchanger where applicable. Inspect combustion vent systems and chimneys, including flue interiors. Inspect accessible flue storage tanks, excluding propane and underground tanks. Inspectors are not required to inspect the interior of flues or chimneys. Test or inspect the heat exchanger where dismantling is required. Determine the adequacy or balance of heating supply or distribution. Operate heating systems when doing so may cause equipment damage or when utilities are off. Inspect humidifiers, electronic air filters, or solar heating systems. Ignite, extinguish solid fuel or gas fires. Identify the type of composition of insulation coverings. Collect engineering data on equipment or distribution system sizing. Dismantle any equipment controls or gauges. Inspect heating systems accessories such as motorized dampers, heat reclaimers, or air purifiers. So under the inspector shall, you got to go over your own state standards, but one of the big things I do when I train my interns is note the presence of heat in every habitable room, because you're going to go into a lot of half baths and such, basement bathrooms, especially, or bedrooms that don't have a heat source. If it's habitable, you've got to put that exclusion into your report. If you're viewing this as a pre-recorded event, your viewing code is WBS 2025. The certificates now are password protected. If you're going to watch one of our pre-recorded videos, you got to write down this code If you don't have the code, you're going to email us and I will immediately send you our password. Thank you. Okay, so briefly, we're going to go over the difference between boilers versus furnaces, the key difference. So as you all know, when you go into a house, you're going to have your client say, my furnace is working, and you'll go downstairs and you'll see a boiler. So you got to make a decision whether you're going to tell them the difference or not. Most of the time, I just sort of tell them, you heat with water, that's called a boiler, air is a furnace. So a boiler is a hydronic system needing water. Heats water or produces steam. It distributes heat through pipes and radiators. It operates under pressure. Most of the time, it's a silent operation. There's no blower noise and can provide both heat and domestic hot water at times. Forced air heats air directly, distributes the heat through ductwork. Atmospheric or slightly pressurized blower creates noise, can integrate with central air conditioning. So I just ran into this a couple of days ago where my client says, at my old house, my heating and air are all one unit. How come my heating and air aren't all one unit now? And I explained to him that you're heating with water and your air conditioning is this two separate unit. This is mainly for newer inspectors. Hot water versus steam systems. Understanding the fundamental differences between hot water and steam systems helps inspectors identify components and potentially issues specific to each type. So hot water systems. Well, we have a closed loop system with circulating pumps, lower operating temperatures between 120 and 180 degrees. They require expansion tanks. They're more common in modern installations, and multiple zones are easily controlled. Steam systems have an open system using steam pressure, which have a higher operating temperature of around 212 degrees, require proper pitch for condensate return, typically found in older homes, air venting critical for proper operation. We're going to go through what circulators are and all this, but this is just sort of a general view of how these different systems work. And what they are. Fuel types and energy sources. Residential boilers can operate on various fuel sources, each with distinct supply components and inspection considerations. So we have natural gas, which is a very common fuel source on the outside of the house, or sometimes even on the inside of the house. You're going to look for a gas meter, a main shutoff valve, and flexible connectors. Check for proper gas piping and support. We have propane or LP gas, requires an external tank. I know in Connecticut, at least in my inspection, I'll only note if I see a tank is really deficient, too close to a window or something like that. But you may want to verify the tank's condition, the proper location, adequate supply lines, check for rust and connection and corrosion on connections. In fact, we have a webinar from forgot the webinar that we did, but we did one on propane tanks and such. Go ahead.
It was Paraco Gas.
Paraco Gas, that's right. So there's a Paraco Gas webinar. You can watch that for proper propane tank and such. Fuel oil, stored in tanks above and below ground. Inspect tank condition, fill pipes, vent pipes, and oil lines for leaks and deterioration. And we have electric, which is less common for whole house heating. There's no combustion components, and you want to check for electrical connections and amperage requirements. So natural gas, when we look for the meter, I know in Connecticut that if your meter's on the inside of the house, you're going to be put on a list by the gas company for it to eventually be moved to the outside of the house. Check for proper gas piping. We have one of our very first webinars was from Robert Torben from CSST, corrugated stainless steel tubing. I'll make sure that's properly grounded or bonded. So those are a couple of things for natural gas. Fuel oil. I had an inspection this last week where the agent said, "We think the oil tank's underground. Can you bring a meter to check to see if it's under the ground, a metal detector?" And I was like, "No, we're gonna call the proper contractor to come out to see if there's an underground tank." When I got there, I saw the oil pipes, the lines leading right through the concrete. So there was definitely an oil tank there, but it's got to be confirmed, which we don't do because it's underground. You can't see it. Distribution methods, how heat travels. Hydronic systems distribute heat through various methods, each with unique characteristics and inspection requirements. So we have our traditional radiators, which can be cast iron or steel units, typically found in older homes. They're heavy, durable, and provide radiant heat. Baseboard convectors, fin tube units along walls, common in modern systems. They provide convective heat distribution. Radiant floor and ceiling heating. Piping embedded in floors and ceilings provide heat distribution, but difficult to access for inspections. So, testing these systems, I have a heat gun. If it's a large house, I keep it right in my pocket and I'll just run around the house, check to see if all the heat's when I'm in each room. And then I'll know if there's no covers over the radiator, especially if there's going to be kids in the house. And I'll let the client know, especially a lot of times I'll find out in a house that the master bedroom upstairs, the radiators are off and they'll want to know why. And I'll say, usually because the room's getting too hot. So the radiant heat from the first floor will travel up, and that's most likely enough. And that's why they had the radiator shut off from the top. Baseboard convectors are pretty easy to inspect. You'll see if there's damage, rust, corrosion, missing convectors. Usually there's missing covers, rust, broken piping, that kind of thing. Piping configurations. So we have a single pipe system, which is one pipe that serves both the supply and return, common in older homes and steam systems, simple but less efficient. Two pipe systems, separate supply and return pipes, better heat control and more efficient, standard in modern installations. And a manifold system, central distribution point with individual zone lines, allows precise zone control, common with radiant systems. So this is pretty self-explanatory here. Again, the single pipe, more with steam systems, the two pipe systems. So you have the separate supply and return pipes, and your manifold you'll see too. Common boiler types. Modern residential installations feature various boiler types, each with distinct characteristics, efficiency ratings, and inspection requirements. Cast iron convectional boilers. Cast iron boilers feature sectional construction for easy repair and replacement, robust and long-lasting although less efficient by modern standards. Key points. What you're going to look for during an inspection is rust and corrosion, water staining or leaking at joints, proper venting through the chimney. You're going to want to determine the age and remaining useful life. These usually work at a lower efficiency, okay? 70 to 85% efficient. And I think we have pictures here. So we're going to see, your rusting, recognize the difference between cosmetic wear and structural failure is a core inspector competency. The following indicators signal that cast iron boiler has reached or exceeded its serviceable life. So you need to know the difference between surface rust and active corrosion. Surface rust is cosmetic. Active corrosion with pitting, flaking, or weeping indicates structural failure and warrants immediate replacement. Rusting, staining on pipes and fitting, orange-brown staining around joints, fittings, signals chronic leaks and ongoing deterioration throughout the system. Boiler section cracking. Rust-induced cracking in cast iron sections is irreparable. Once sections crack, full boiler replacement is the only safe course of action. And end-of-life indicators. Age over 30 years combined with active corrosion, frequent repairs, or rising fuel bills is a reliable signal that replacement is overdue. So you've got to inspect these systems really carefully. When I get to an inspection, I usually start right at the top. If it's an oil-fired system, to see if there's a fire-o-matic, which will shut the unit off. I'll tap the expansion tank to make sure it's not filled with water. I work my way down to make sure all the wiring and everything is nice and secure and neat. I'll go to the service tag. A lot of times there's going to be a serial number there or the age of the unit there. I'll note that. And then I just do a general evaluation of the unit. I'll determine how many zones there are. again, like the age of the system, I'll have the unit fired up and running when I'm down inspecting it. I do test the shutoffs. Some inspectors don't. I will just let my client know where it is on the age of the life. Recommend I'll check the service tag to see when the last time it's been serviced, and sort of give my client an idea where we are on the life cycle with the unit. I do try to run all the zones all the time. Okay. And then so I'll turn on all the thermostats, but then what I'll do is I'll physically touch the zone pipes coming out, the supply pipes coming out, to see if they're warm or hot, and see if the circulators are working. So that's what we do there. High efficiency condensating boilers. Modern condensating boilers extract additional heat from exhaust gases, achieving efficiency ratings of around 90 to 98%. They produce acidic condensate that must be properly handled. Key inspection points: verified PVC or stainless steel venting, check condensate traps and discharge lines, look for condensate neutralizer if required, inspect intake air piping, verify proper condensate disposal, check for freeze protection on outdoor venting. So that's a little checklist there. It's the same kind of inspection I do with the boiler. I will look for the neutralizer. I also check for proper condensate disposal. Now, if it's a septic system, I've been in inspections where enough of them where if I've lined 20 septic guys up, 10 will tell you that they don't want the condensate going into the septic system, and 10 will tell you it's fine. And the 11th will tell you it's okay that it's draining right into the ground. So I just want to make sure it's draining someplace and it's not going to back up. And if my client says, is it okay to go into the septic? I usually tell them the less water that we can put into the septic that's not what we put in is fine, is better. But I usually don't have a problem with it. But you got to listen to your septic guy because that's his purview on what you should do.
To your point, Jim.
Yeah, go ahead.
At least all these new condensing, the condensate is very acidic, really acidic. So it's required that there be. I see so many that don't have neutralizers. I have one. I have a neutralizer on both my water heater and my furnace, which is both high efficiency. And even with, I have mostly PVC, but I have cast iron on the ground. It's recommended to put that. If you don't, it could be a tube. It could be actually in the condensate. In the condensate pump, you'll see little stones in there, limestone. So if you don't see, I make note of it. Listen, we're not required to make note of it. I always mention it. And to Jim's point, if it is a septic, you don't want acidic condensate going into that septic. But usually, if it's just air conditioning condensate, you can go outside. But because now all these high efficiency tankless water heaters, combination water and heat, they want that condensate to go into a moisture trap within the house so it doesn't freeze. And every once in a while, I'll see it going outside, and I'll make note of it, or you'll see it if it's real cold, if it's freezing up. But
Scott, question for you. For newer inspectors, when you go see the unit on a high efficiency condensating boiler, how do you determine that it's a high efficiency condensating boiler and that it may need or require a neutralizer?
Well, how it's vented too, because now you're reusing a lot of that flue gases. So if you see a pipe going out, sometimes you'll see concentric. If you look on the outside, you'll see a sidewall vent, or you could see a gooseneck, one up, one down, one's intake. I can't even do it on here. One pipe is exhaust, one is intake. If you see that, it's a condensing boiler. If it's going up the chimney, natural draft, then it's not. And that's the same thing with a water heater. And I've talked to so many different guys. It should be piped to the outside. So if you see any one of these condensing boilers and they have the little pipe sticking on top because they're being lazy, I mean, they're the manufacturer they want to see it piped outside, taking air from the outside. You'll get some guys that they'll say, oh, it creates condensation and rust on it, but they should be piped outside. And in one of our pictures, you'll see the exhaust. They'll use Schedule 80, which is the gray stuff. and then they'll use PVC for the intake, and they use both. It's acceptable, but that's how I usually tell. I mean, if it's got PVC pipe, it's condensing, and whether it's a water heater or it's a boiler or a combination boiler hot water.
Okay, great. Combination combo boiler units. Combo boiler provide both space heating and on-demand domestic hot water from a single unit, eliminating the need for a separate water heater. These compact units are popular in smaller homes and condos. Advantages: their space-saving design, no separate tank, continuous hot water supply, and their high efficiency. The limitations: limited simultaneous hot water flow, higher demand on system, potential for inadequate capacity in larger homes. Inspection focus: test both the heating and the hot water functions, check the water pressure, verify adequate capacity for a home size. That's a little difficult to do that during the inspection. I can tell you, I did an inspection in Glastonbury for a couple that I knew, and it was a 4,000 square foot home, and they were of Indian descent. 2 people living in the house, and they had one of these small boilers that did both the hot water and the domestic hot water. And they were fine until Christmas, when her family came from India, about 15 people, to stay over the house for 2 weeks. And she called me up and she goes, "We're consistently running out of hot water." And I said, I told you this, that your system was not going to be handled large groups of people because of the size of your house. So they had to, and that was in the report. And all my reports where it's one unit doing both, I have a disclaimer in there that says the hot water is one, but this is not something that determines the adequacy of that hot water in all conditions. So I said the best thing to do right now is, because it's the holidays, you're not going to get anybody in there that quick. Schedule somebody to come in to put a water heater in or a storage tank, and then you're going to have to give 10-15 minutes in between showers so that the system has time to recuperate.
The other thing too, Jim, not to interrupt you, but
no, go ahead.
With those combination boilers, you got to remember, if in the summertime you're not using heat, right? You're just using hot water. I have a tankless water heater, and then I have a separate furnace. I never run out of hot water ever. Sometimes in these larger, but the only downside is, it takes a little longer to get the hot water. Once I have it forever. But when you have a combination, remember, when the heat's on, it'll switch. If you're turning your heat up, it's calling for heat. It's going to send the hot water. It's going to send the priority. It's going to heat up the hot water for heat, and maybe not such for the domestic hot water. So with 13 people in the house and everybody the heat up and all that. So sometimes you can put a pressure booster if you can't get enough hot water to the far side of, say it's a big house. A lot of times, sometimes they'll do separate units and just so you have enough hot water, or they'll put a booster on there to get more hot water there sooner, because it takes longer. I mean, with a hot water heater, you have instant hot water. With these, sometimes you got to turn the shower on, brush your teeth, and then jump in the shower.
Right. I tell people with these units, during the winter, strong winter, when it's cold, this unit will instinctively want to keep you alive before it keeps you clean. So it sort of lets the layman know it's going to heat before you're going to wash your hair.
Correct.
Wall hung versus floor mounted. Wall hung units have compact sizes, so they're space-saving design, typically lighter weight, often high efficiency models, easier to access for service. And then you want to verify adequate clearances. Floor mounted units, traditional configuration, heavier cast iron construction, more stable installation, may require more floor space. You want to check for proper support and look for water damage on the floor. Also on the wall hungs, you want to check for mounting security. I like here what they have is they put the plywood. The system's very neatly organized. Everything's plumbed out. And the neutralizer might be, like Scott said, in the circulator pump here. I'm old enough to remember when these units didn't exist, unfortunately. And when they first came out, they sort of, in my opinion, they had a little bit of a bad rap that they weren't going to last long. But now I've been inspecting for many years now, and these units, I'm coming into older units from 2008, 2007, and they're lasting. So I tell people they should last as long with proper maintenance as a traditional boiler. So, and they have to, and the other thing too, as I stress with my clients on this kind of thing, is you have to get these things serviced. A lot of people think because they're just so small, they're hanging on the wall. It's gas, it's propane, it burns clean. I hear this all the time. You don't have to get it serviced, but you do. Every single year, you should get it serviced, clean service, and vacuum down. Steam boilers, critical boiler components. Understanding key components helps inspectors identify potential issues, communicate findings effectively to clients. Burner and combustion chamber. So now we're going to go through each system. The burner mixes fuel with the air and ignites it within the combustion chamber. The heat exchanger transfers this thermal energy to the water. These components are critical for safe, efficient operation. So the inspection points: look for rust, corrosion, or deterioration on the burner assembly. Check for proper flame pattern during operation. You want to see a nice blue steady flame. No yellowing, no wavering gas too much. You want it to be very steady. Inspect combustion chamber for cracks or damage. That's going to be hard in a lot of systems. Some of the older systems have little sort of view chambers that you can move to see in there. Look for soot buildup indicating incomplete combustion. Note any unusual odors during the inspection and verify proper burner access panels are in place. Combustion chamber. So again, I just put this into we put this into the PowerPoint just for informational purposes only. You're not going to be able to see most of the combustion chambers that you run across. So we have a refractory lining. Chamber walls are lined with heat-resistant refractory material that reflects heat back towards the heat exchanger and protects the boiler jacket from extreme temperatures. Burner assembly. The burner introduces a fuel-air mixture into the chamber. A proper flame pattern, blue and stable, indicates correct combustion and efficient fuel use. Heat exchanger surfaces. Combustion gases transfer thermal energy through the heat exchanger walls to the water. Inspect for soot buildup, scaling, or corrosion that reduces efficiency. Inspection access. Most chambers are accessed via removable panel or observation point. Inspect for cracks, deterioration, or evidence of flame impingement on surrounding surfaces. Honestly, for every 100 systems I inspect, very rarely am I going to see the inside of that unit. It does happen, but I have information, as you should in your report. These systems should be cleaned and inspected prior to the sale, and if not possible prior to the sale, immediately upon thereof transfer of property, or if you've not had a tag within the last year, to get somebody in there to take these units apart. They need to be vacuumed and cleaned every year. Circulator pumps and zone valves. These components control water through the heating system, enabling zone heating to ensure proper circulation. Circulator pumps, electric pumps that move hot water through the system. Check for leaks at flanges, unusual noises, excessive vibration, and proper mounting. Verify electrical connections are secure. Zone valves, motorized valves that control flow to individual zones. Test operation when possible. Check for leaks at the valve bodies. Verify proper wiring and ensure manual operation levers function. So the older systems, you're going to know. If you run it, I've run into systems where they're 40 years old and they look like they just came out of. They look like a car that's just come out of the showroom. You have somebody there that went down in that, that cleaned that unit every week. And if you were a layman, you're just walking by, you're like, man, that's a real nice heating system. But then I'll look at the circulator and, it's the size of a football. So it's an older system. So take a look at your circulators. Again, you're really checking for leaking, rust, and operation. You'll hear them when they're running. Expansion tanks, managing pressure. Expansion tanks accommodate increased water volume as it heats. Water expands and contracts, preventing excessive pressure buildup in closed hydronic systems. Two main types exist: older steel tanks and modern diaphragm tanks. Steel expansion tanks, partially filled with air and water, may become waterlogged over time, requiring drainage and air recharge. Diaphragm tanks, modern design with flexible membranes separating the air and water, pre-charged, maintenance-free, and more reliable. Inspection, check mounting security, look for rust corrosion, tap the tank to hear if it's waterlogged, the dull thud, verify proper size for system, and inspect connecting piping. So the steel tanks, I don't see a lot of them anymore. I do see them. The diaphragm tanks I see all the time. I do tap on them. As for the installation, I've seen them installed vertically and horizontally, and my heating guy tells me both are acceptable. I don't like the horizontal installation because I think that if they fail, that's gonna put stress on the threads, but my guy keeps telling me I'm wrong. So I do mark it if it's horizontal, but a lot of times I'll see them horizontal with a piece of wood in case it fills with water. That's not going to do you any, underneath it, and that's not really going to do you anything if it fails. Air management components. Air in hydronic systems causes noise, reduced efficiency, and circulating problems. Several components work together to remove air from the systems. So we have air separators, which capture air bubbles from circulating water and directs them to an automatic air vent, usually installed on the supply side near the boiler. We have automatic air vents, flow-operated valves that automatically release air without allowing water to escape. Check for leaks and mineral buildup. Manual bleeders, located on radiators and high points, require periodic manual operation to release trapped air. Verify that they operate and don't leak. Probably not going to do that. These two we see a lot, especially the automatic air vents, and these do fail. And this top here, you'll see homeowners will screw this down because they think it's loose, and that's not supposed to be screwed down completely tight because it needs to allow the air to come out. Safety relief valve, the critical safety device. The safety relief valve is the most important safety component on any boiler. It prevents catastrophic pressure buildup by automatically releasing water if pressure or temperature exceeds safety limits. So proper installation. Valve must be sized correctly for the boiler, BTU rating, and installed directly on the boiler without any shutoff valve in between. Discharge piping. Fully sized pipe, usually 3/4, must extend within 6 feet of the floor and terminate safely with an air gap, never capped or plugged. Critical defects. Missing valve, undersized discharge points, discharge pipe directly where it could cause injury, valve actively leaking or corrosion. So pretty simple. We like to see them an inch or two off the ground. Do not test these. And you want to just note if they're not missing. A lot of times from newer inspectors, you'll see them missing, and it's in such a tight, confined space, and where it would discharge is facing the back of the foundation or something. It's not going to actually hurt anybody. But I tell people you still want that valve installed because you don't want water going everywhere, and you want to be safe. Pressure, temperature gauge, and low water cutoff. So pressure and temperature gauge displays the system's pressure, the PSI, and the water temperature. Normally operating pressure is typically between 12 and 15 PSI for residential systems. Temperature varies by system, but typically usually is 140 to 180 degrees for hot water systems. Red flags, pressure above 30 PSI, pressure near zero when system is cold, gauge not functioning, or missing gauge. And you're going to see your safeguard low water cutoff, a safety device that shuts down the boiler if the water level drops too low, preventing heat exchanger damage or potential safety hazards. Essential on steam boilers. Some hot water systems also use them. So for the inspection, you want to verify the presence on steam systems, check for visible damage or corrosion, and note that the functional testing requires specialized knowledge. So you're not going to sort of test these systems there, but you want to make sure that they're there. safety control and devices. Multiple control systems work together to regulate boiler operation, maintain comfort, and ensure safe operation. Thermostats and zoning. Thermostats control when the boiler operates based on the temperature demand. Modern systems often feature multiple zones, each with its own thermostat, allowing different temperatures in different areas of the home. So we have our single zone systems, the one thermostat that controls the entire house, which I wish I had, but we don't. Simpler but less flexible for comfort. Multiple zone systems, multiple thermostats control different areas, uses zone valves or multiple circulators. More complex, but offers better comfort and efficiency. Inspection focus, test thermostat response, verify system response to temperature changes, check for proper wiring, and note if the zone operates independently. So I was at a condo in Cromwell training my intern. We did the outside of the condo. There was a brand new condenser outside, 2026. We go into the condo. It is a garage underneath. All the ductwork is running through the garage. Safety issue there. The heating system was in a little closet, as you all probably have seen 1,000 times. The heating system was 38 years old, and on top of it was the brand new air handler, which was amazing to me that you would not just make the investment for the heating system. I said to my intern, go upstairs, turn the air conditioning on. He ran the air conditioning. I said, turn it off. We're going to let it sit for 2 minutes, and then we're going to turn the heat on. And the heat did not come on. We heard the thermostat demand the heat, but the system did not turn on. The listing agent shows up and says, you guys don't know what you're doing. I'm going to put it on fan. And the system starts blowing air. I said, that's great. You're moving air, but you're not moving heat. And why would somebody not replace a 38-year-old unit and put something that's brand new as an air handler right on top of it? So all the people who installed it, probably last week, they have screwed up the heating system. So you want to test and make sure everything works from every thermostat, if possible. And carry extra batteries with you, because you're going to come into homes where thermostats have lost batteries, the batteries are low. So it's nice to have that set, because it's easier for you to shove a battery in there for 10 minutes and make your report writing easier than having to write up a defect, in my opinion.
And just to add to that, Jim, too,
Sure.
guys, I'm sure everybody's had that happen before. You got to have, if it's in heat mode on the main floor, and say you got to switch it over to cool or heat in order to get the other zones to work on a lot of houses. So in other words, if you want to turn the second floor on and you're in heat, and just say you're checking the heat, you let it cool down, and you switch over to AC, you got to go back down and make sure that downstairs is on cool. It may not. You'll sit there trying to turn it on and it's not going on. So just keep that in mind with multi-zones.
Aquistats and high limit controls. These temperature sensing controls protect the boiler and maintain safe operation conditions by monitoring water temperature. An aquistat controls boiling temperature by cycling the burner on and off, maintains water temperature within a set range even when no heat is being called for. Typical settings range from 140 to 180 degrees. Check that the boiler maintains temperatures and cycles properly. High limit control, safety device that shuts down the burner if the water temperature exceeds safety limits, typically 200 to 240 degrees, prevents overheating and potential pressure buildup. Cannot be reset until temperature drops. If frequently tripping, indicates a serious problem requiring immediate service. So this is just to know what these systems are for newer inspectors. Emergency shutoff switches. Emergency shutoff switches allow quick disconnect of power to the boiler in case of emergency or during service. These are required by code and are essential safety devices. Location requirements within sight of the boiler, at the top or bottom of the basement stairs, clearly labeled as emergency shutoff boiler. Red cover plate, typically easily accessible without removing obstacles. Red flags would be switches missing, improperly located, not labeled, or obstructed by storage. So a couple of things that you're going to run into is when you're walking down the basement stairs, turn left or right to see if there is a shutoff switch. If it is a gas unit downstairs, there might not be, especially on newer construction, a shutoff switch at the top. They are not required. They're just required on the unit. The reason for that is because If there's a problem, it's a gas unit, they want you to go downstairs and smell and see what's going on. You might have a conversion from oil to gas, and then they still have the shut off at the top of the stairs. I still test that to see if it shuts the unit off, and I will inform my buyer that don't want to really use this switch, only in extreme circumstances. You want to go downstairs and see what's going on because it's a gas service. And then you'll see a lot of times, go ahead, sorry. Oh, okay, no one's speaking. If you can mute yourself, that'd be great. You'll see a lot of times that people will take these plates and they don't like the red and they'll turn them off. They'll switch them out for a real clear plate or something. And for newer inspectors on the older houses, those shutoffs are at the bottom of the stairs to the left or the right of the stairs in the basement. Venting arrangements, getting combustion gases out safely.
Can I just say something real quick?
Absolutely.
I ran into a situation recently on like a smart home.
Yep.
And when I tested the shut-off switch, it would not allow the system to turn back on again without the owner putting in a passcode.
So we have to be careful. That's great. Thank you for that information. You know, I will test them on what I think is a normal unit, and that's a good point. But so if you see a modern home with these new thermostats and alarm systems and everything, you might think twice about turning those units off and on. Okay, so venting arrangements, getting combustion gases out safely. Proper venting is critical for safety. Combustion gases must be removed from the home to prevent carbon monoxide exposure and ensure efficient operation. Chimney venting systems. Traditional boilers vent through masonry or metal chimneys using natural draft. The hot exhaust gases rise through the chimney, drawing fresh combustion air into the burner. Vent connector. It's a metal pipe connecting the boiler to the chimney. Must be properly pitched upwards, 1/4 inch per foot minimum, supported every 4 feet, and made of the appropriate material for the fuel type. Chimney liner, clay, metal, or cast in place liner inside masonry chimney, required for most boilers to prevent condensation damage to masonry and ensure proper draft. Inspect visually where accessible. That's huge. You're not going to be able to see a lot. Common defects. Back pitch vent connectors, excessive horizontal runs, rust corrosion, disconnected sections, improper materials, PVC on atmospheric vents, missing chimney liners, or blocked chimney. We did continuing education many years ago, and I got so freaked out about proper chimney venting. I put a disclaimer in all my reports to make sure that they have, if the system's been changed or upgraded, and just in general stuff that I can't see, to have a chimney company come out or a heating company come out to make sure that all the venting is appropriate and sized correctly for the system that you have. So that's in there in the reports. Direct vent and sidewall venting systems. So for high efficiency configuration, the modern condensating boilers typically use PVC or CPVC vent piping through an exterior wall. A sealed combustion system draws air from the outside and exhausts through the same wall. Advantages: no chimney required, sealed combustion, higher efficiency, and flexible installation. So the key inspection points would be verify proper PVC and CPVC material, which is white or gray. Check for proper slope towards the boiler. Inspect termination clearances from windows, doors, mechanical equipment. Look for ice buildup in the winter or evidence of blockage. Verify separate intake and exhaust pipes, and check for proper support and secure joints. Ensure termination has proper screens and guards. Anyone have proper height outside also. So these are a couple of things that you have to look for. Pretty simple here. Critical safety issues, venting defects. Improper venting can allow, the other thing too is, a lot of times they'll take the combustion air right from the basement. And I'm not a big fan of that. I like to see that extra pipe taking it from the outside of the house. Improper venting can allow deadly carbon monoxide to enter the home. Any evidence of fuel gas spillage, backdrafting, or compromised venting requires immediate action. Signs of venting problems: soot deposits around vent connectors or draft hood, rust stains or water damage near venting, melted plastic on nearby surfaces, strong combustion odors during operation, and condensation on windows near boiler during operation.
Jim, hold on. I just noticed it now.
Sure, go ahead.
There was a question. Do you call out natural gas boilers venting in the chimney doesn't have a stainless steel liner?
Yes.
I always, to Jim, what he said before is they should have a metal liner. A lot of times when they go from oil to gas, they should line it, and they don't, or at least have that liner. That, you know, most of the liners are all spalling, they're broken, and et cetera. So you'll see it on top. For one, if you go up on the roof, you'll see if there's a liner. If you can't see it and you're not sure, like Jim, I have a disclaimer that says I have somebody clean, inspect, and verify that the chimney is properly lined. So I do mention it. There's nothing wrong with mentioning it. Just cover yourself, you know.
Combustion air requirements. Boilers require attic air for complete combustion. Insufficient combustion air leads to incomplete combustion, carbon monoxide production, and poor efficiency. The amount of air required depends on the boiler size and whether it's atmospheric or sealed combustion. Indoor air sources. Atmospheric boilers draw air from the surrounding space. The room must be large enough or have openings to provide adequate air. Dedicated outdoor intake. Sealed combustion units draw air directly from outside through dedicated piping, eliminating concerns about room size. This is something that you're not going to do the math on, but after a certain number of inspections, you're going to go into a room, sealed boiler that does not have enough combustion air, and you're going to note it. You know, a lot of times you'll see them in the closets or whatever. You want to see louvered doors. You want to see exhaust air, like the fan in the can, so that you can get air from the outside. So use your common sense. If your spidey sense goes off and you think the room's too small, there's not enough combustion air, you can't go wrong saying that. The worst thing is your client will call you and tell you, my heating contractor says it's fine. Well, you know, good for you. That's good. Viewing code. If you're viewing this as a pre-recorded event, your viewing code is HWS 3821. Red flags for combustion air issues. Identifying potential combustion air deficiencies is critical for safety. Look for these warning signs during your inspection. Tight, sealed spaces. Boilers located in small, tightly sealed room with no openings for air. Modern weatherization can create this problem in older homes. Blocked air openings. Require air openings recovered by storage, sealed over during renovations, or obstructed by debris. Missing louvered door. Boiler closet doors should have louvers or undercut for airflow. Solid doors without openings restrict air supply. Competing exhaust fans. Powerful exhaust fans like kitchen, bath, whole house can depressurize the home, causing backdrafting at atmospheric vents. Condensating handling and high efficiency units. Condensating boilers extract so much heat that water vapor and exhaust gases condensates into a liquid. This is acidic condensate must be properly managed. Condensate production. High efficiency boilers produce acidic condensate 3 to 5 pH as water vapor condensates in heat exchangers. Trap installation. A condensate trap prevents exhaust gases from escaping through the drain. Must be properly filled and sealed. Neutralization. Some jurisdiction requires condensate neutralizer to raise the pH before discharge to protect the drain pipes and septic systems. We've talked about this. Proper discharge. Condensate must drain to an approved location, the floor drain, condensate pump, or the outside with freeze protection. So like you see here at bottom here, it's just going in to a drain to the bottom right of your screen. You see that all the time. Condensate acid neutralizer. The purpose and function of acid neutralizers. Again, the high efficiency boilers produce acid condensate with the pH typically between 3 and 5. This acidic discharge can corrode standard drain pipes such as copper and cast iron, damage septic systems, and negatively impact the environment. An acid neutralizer is a device designed to raise the pH of this condensate to a safer, more neutral level, typically pH of 6 to 8, before it is discharged into the drainage system. It consists of a chamber filled with an alkaline neutralizing media, commonly limestone, marble chips, or crushed seashells. As the acidic condensate flows through this media, a chemical reaction occurs, neutralizing the acid and preventing potential damage to plumbing infrastructure and the wastewater treatment process. So we talked about this. It's a little bit of a review. The key inspection points: make sure it's installed, confirm the sizing, it's appropriate for the boiler's BTU. Media level, inspect the neutralizing media level. It should be sufficiently full. Depleted media level indicates need for replacement. That's how many pellets and stuff are in there and the size of them. Drainage, ensure proper condensate flow through the neutralizer, that there's no leaks or blockages, and check for evidence of regular maintenance, such as media replacement records. Common condensate system defects: improper piping material, PVC, CPVC, or specialized material required for acid condensate. Standard metal piping will corrode rapidly. Missing or dry trap. Traps prevent exhaust gases from escaping through the drain. Missing or dry traps allow dangerous gases into the home. This is all trap. Floor discharge. Condensate draining directly onto the floor or ground creates moisture problems, potential freeze issues, and code violations. Distribution system inspection. The distribution system carries heated water from the boiler to the radiators or baseboards throughout the home. Proper inspection identifies leaks, corrosion, and functional issues. Piping material and conditions. Hydronic systems use various pipe materials, each with specific characteristics and potential issues inspectors should recognize. So copper piping, which is common in modern systems, you want to check for green corrosion indicating leaks, physical damage. You want to look for proper support of the pipes and evidence of previous repairs. Look for pinhole leaks in older systems. Steel piping, common in older homes and steam applications. Check for rust, active corrosion, leaking joints, evidence of prior leaks. Threaded connections may weep over time. And PEX tubing, flexible plastic tubing used in modern radiant systems. Check for proper support, protection from UV light, damage from pests, and proper connection methods. Circulator pumps, inspection points. Circulator pumps are the heart of the hydronic system, moving hot water through pipes to heat emitters. These electric pipe pumps run continuously, or cycle based on thermostatic demand. Visual inspection. You want to, again, check for the mounting, secure proper orientation, look for water staining or corrosion at the pump flanges, inspect the union connection for leaks, verify electrical connections. We've been through this, and look for the rust on the body indicating leaks. You'll want to listen for any unusual noises like grinding or squealing, feel for excessive vibration when running, and check to see if the pump feels warm. Note if the pump starts when heat is called for. That's a little bit of a review here. Radiators and baseboards, common issues. Heat emitters are the final component of the distribution chain. While generally simple, they can develop problems affecting both function and safety. Physical damage. Dents, cracks, or damage to the radiator bodies or baseboard coverings. Damaged radiators may leak. Missing baseboard covers expose hot fins, creating burn hazards and reduced efficiency. You want to look for leak and staining at the stems, unions, or radiator bodies. You want to look for water on the floor, especially by the legs and stuff. Mineral deposits. Air trapped in systems, radiators that don't heat evenly or remain cold when the system operates, gurgling noises during operation, air bleeder valve stuck or corroded, preventing air release. So these are safety concerns. Hot exposed surface at sensible heights, creating burn risk, especially near children's areas. Radiators use as support for storage, create tip over hazards, sharp edges, and such like that. I always say if you've got radiators and kids, you want to put covers on them, especially if they're young. Steam specific issues. So on these steam systems, steam vents on radiators, small air vents on radiators allow air to escape so steam can enter. Check the valves, check that the vents are present, not painted shut, and operating correctly. Hissing during heat up is normal, consistent leaking is not. We want to look for a proper pitch. Steam pipes must be pitched properly for condensate to drain back to the boiler. Improper pitches cause water hammering, noise, and poor heating. You want to look for sagging pipes or reverse pitch. Water hammering, loud banging in the pipes during operation indicates condensate trapped by improper pitch, wrong piping sizing, or failed steam traps. This can cause the pipe damage and the system to failure. So if we're following a consistent inspection procedure, this ensures thoroughness and prevents overlooked offense. This should be for all your inspections. I'm a pretty boring inspector in my own world. I do the same thing every single day because I don't want to miss anything. If you get into a good routine, you shouldn't miss anything. So again, start from the bottom to the top to the bottom, come up with your own thing that makes you feel comfortable that you're not going to miss anything. So we want to, before operating any boiler, we want to do the following. We want to check clearances to combustibles. We want to assess service access, look for visible leaks, corrosion, and staining, examine venting systems, and we want to verify the safety component of presence. So we want to make sure there's adequate space around the boiler. We want to ensure that there's room for technicians to work. We want, again, on all these things, we want to look for leaks, corrosion, and staining, examine the venting system, and again, confirm the relief valve, expansion tank, etc. If conditions permit and it's safe to do so, observe the boiler during operation. Set the thermostat to call for heat. That's kind of obvious. Does it start? Does it shut off? Is the flame stable? We've been all through this. During operation, you want to pay attention to unusual noises, strange odors, excessive vibration, smoke or soot around the boiler, water leaks, and system cycling behavior, short cycling, failure to maintain temperature. Major safety red flags: fuel gas spillage, relief valve issues, burn marks or overheating, severe corrosion, fuel leaks, inadequate combustion air. We've been through all these. So these are critical safety defects that you want to make sure that are in your reports if you see anything. And stuff can get bad enough if you go into a house. It happened to me twice where there's gas leaks. Inspection over, call 911 and get everybody out of the house. When to recommend immediate service. So, you have to know if something's going wrong, shut down immediately. You want to have that service before the next operation. Check your service tag so that I always put it in if it's not been serviced within the last year. And I always tell my home buyers, listen, you're not in a condo, but you should have your own little HOA. And they're like, what are you talking about? I'm like, your system's 38 years old. Nobody has any money. You need to start saving money now so that you can replace the system because it's not going to last forever. I don't like hearing that. Age, life expectancy, and documentation. So determining the boiler's age helps assess remaining useful life and replacement planning. You want to look for the data plate, serial numbers. This is kind of crazy. The first 2 or 4 digits may indicate the year. There's plenty of resources now where you can find the age of something. The model number sometimes indicate the year, very rarely. When the age is unclear, use language like appears to be original, age cannot be determined, but appears older, this kind of stuff. You want to do your best. If you've seen enough of these heating systems, when I train my guys and girls, I tell them, you want to not look at this tag until last thing. You should be able to look at a system without looking at the tag to see how old it is, like you do a roof. Old teal tank expansion. So just here's a little picture. This tank was not active, but the client was concerned about how tough it was going to be removed. And I tell them it's tough enough that the last people just left it there. It's not hurting anything. But if you want it removed, call a heating contractor. They'll come and they'll cut it out. Life expectancy guidelines. This is, it depends upon the model and brand, as you all know. But cast iron boilers, they last a long time. 20 to 30 years. I usually tell my clients 25 to 30 years. High efficiency units, I usually go 18 to 22 years. And combo boilers, they're saying 10 to 15 years. I think they're lasting longer. And again, these are general ranges, poor water quality, lack of maintenance. I'll have someone call me up and they're like, hey, I bought a house 10 years ago. You said the water heater was new or the heating system was new. I'll go out and take a look at it. There's no tag. You've not got it maintained in 10 years. Did you think it was going to work? Boiler inspection reporting. So again, in all our webinars, we are hitting this 4-point observation, implication, recommendation, and limitation. I have switched 90% of my report. I'm in the process of upgrading my reports to do an operation of a factual description of what you found. The relief discharge pipe terminates 18 inches above the floor and is directed towards the electrical panel. The implication, which is huge now for newer agents and first-time home buyers. Why is that bad? It explained why this matters is the configuration could spray scalding water everywhere. And then you're going to put your recommendation is to have a qualified plumber extend the charge pipe within 6 inches of the floor. And then limitation that we don't test these relief valves. And thank you for attending. We're at 8:03. We hit it right on the mark, a little bit over. Let me just get rid of stop screen sharing. And does anybody have any kind of questions or anything? We got through this pretty good today.
Robert had just mentioned, and it's actually, it's true, and probably because they're old, is loose and flaking paint on a radiator could contain lead. So, that's like any other old house, but with flaking paint, windows, doors. So that was good. And I like the IR, Ed. Ed uses infrared when he's checking the radiators.
Nice.
So I always call out when I see like rust or debris in the sight glass on a steam system. I always tell my clients that might be an indication that there's deterioration within the radiators, within the circulation pipes.
Yeah, and even if you're unsure, if it hasn't been serviced, I always recommend having it clean, serviced, repaired, whatever words you want to use, prior to purchase or after. And then I always recommend to have the system serviced annually, because most people, they buy a house, if they ask you to come out in 5 years, they haven't got a service contract. They don't maintain anything, and that's really important. And yes, let's say if you smell even a minor smell of gas, and sometimes when I smell anything on natural gas, propane, more so natural gas around here, a lot of times the gas company will be out like within a half hour because it's considered an emergency. And I've had those guys argue with me and say, well, everything's good. And then they bring out, they'll soak it up. A lot of times their meters are very sensitive, and then they find it because those guys sometimes can't smell it. But, we all walk in the house. If you walk into that basement and you smell natural gas, something's leaking. It's usually the old shut-off valves. I see all the time, all those old shut-offs, they're all leak. Or they're at a union. So if you smell something, there's definitely a leak in it. And
just to wrap up, what I I'll ask my clients it is 8 o'clock, so we're going to have to shut down. But I'll ask my clients: have you ever owned a house or been in a residence that uses natural gas or propane as your fuel source? And if they say no, I'll go, do you know what to do when there's a gas leak? And they'll say, well, yeah, I'm going to shut off the lights. I'm going to open up the windows. I'm like, no, you're just going to leave the house, go outside and call 911. If you shut the lights off, that causes a spark. I know for a fact that they don't want you to open up windows because the fire department wants to come in and take readings of what the levels were so that they can have an understanding of what's going on. So, know who your client is and know how to educate them at the inspection is pretty good. So.
And yeah, every once in a while, somebody will say they'll say they have a smell. It's a dead mouse, but which I can tell the big difference between a dead mouse, but people confuse the two. Gentlemen,
thank you for coming tonight. And I'm just going to stop the recording.